Good afternoon. Welcome to lecture number 6 for Packaging 450. Today we're going to finish up chapter 2. I will go over the homework for chapter 2 that is due on Monday at 10 a.m. And if you have any questions, remember I have office hours tomorrow from 4 to 5, so feel free to come to the office hours or send me an email. I've been getting everyone's email, so thank you for that. Great questions. Keep the questions coming, and I will hopefully see you in office hours tomorrow. I will share my screen. Okay, so one of the things that I wanted to do really quickly was to just give a quick summary of a couple of items that are related to chapter 2. As we talk about program management, I was stressing in the lecture yesterday about how important it is to make sure as a packaging engineer or being in the packaging function that you tie in with the program management team. So here are some of the things that you're looking at. So, and I mentioned also a lot of teams and functions across the whole process that you'll be working with, from manufacturing to development, purchasing. So I wanted to go over those a little bit. From the point of view of inbound, meaning the products that are coming into whatever your plant is. So if you are a tier 1, you're looking at inbound, what's coming in from your tier 2, so or sub tier, your supplier to you. If you're an OEM, you're looking inbound, what's coming in from your tier 1, so what's coming in from your direct supplier. And you'll tie in with packaging as it relates to quality. I mentioned the PPAP, which is the pre-production approval process, and making sure that the packaging protects the product and works well online. Safety, so if you have any ergonomic concerns with how the product is coming out of the pack, or anything else that could impact from a safety standpoint, such as strapping. A lot of times metal strapping is not even allowed in a plant because it can cause pretty serious cuts. So that's an example of something you want to make sure when you are working on packaging standards, not just in automotive, but in industrial or anywhere that uses strapping, that they are not allowed to use metal strapping. Things like right sizing. Right sizing is the process of determining how many parts you go in a pack. So you might come up with a package that covers, that will hold 8 products in it, but maybe those parts are hitting each other and scratching each other. So maybe they need to be separated. Can you separate them with material that protects the Dunish that protects it, or do you actually need to separate the parts even further? And now you end up with maybe 8 in the pack. Normally, right sizing is a process of looking at how can we get more parts in a pack. So you want to make sure that, if you can get more parts in the pack, ship the package and the product arrives safely to its destination, and operators are able to take the parts out line side without any issues from an ergonomic standpoint or from a damage standpoint. Then those would be good candidates for right sizing. Next, another area is in production. So packaging comes into play when you look at production processes as it relates to quality, as I mentioned before. The line side delivery, which is going to tie into things like safety and ergonomics, but it also ties into the speed, the line speed, because if they're able to pull the part out of the pack quickly without causing issues, it helps them to keep on that tack time, which is usually going to be about a minute, is generally the guideline for most automotive facilities, which ties right into productivity, which means getting as many parts or parts produced, or as many vehicles produced as you can to meet your goals. And then for lean, packaging comes into play because it helps with so many areas of efficiency, within manufacturing. It can help with looking at how you get the process as efficient as possible. And a lot of times packaging can be a really good tool for that. So when you've got, racking, can you move the racking in a different location or change the height? That will improve the whole process. So maybe an operator is not bending, or maybe you can develop a pack that helps with a lift assist, and that will help with the lean process, or a pack that reduces the number of steps. And then also just having a place for everything with the standard pack. It helps you to show where your packaging is going to be, where your parts are going to be. And it drives standardization, which is one of the cornerstones of lean. From an outbound perspective, you can look at finished vehicles for packaging and how that plays in to shipping out. I think I mentioned I work for one company that they would ship, they had smaller vehicles, and they were actually able to fit vehicles on a truck. They were able to fit 2 vehicles side by side. They decided, big tires are in, that's really popular. People want rims and those sorts of things. So they put bigger tires on the vehicles. And then when they tried to put them in the truck, they could no longer put them in 2 side by side. So now they're losing half of the density of what they were shipping out. So now they basically need twice as many trucks. So their solution was to, increase labor, put smaller tires on, and then when the vehicles would get to their destination, those tires would ship with the vehicle, and then at the destination, those wheels could be installed, the big wheels. So an added cost that was unexpected, but way less expensive than shipping these vehicles in twice as many trucks. So, that would be an example. When you look at things like aftermarket, just 1 second here. Sorry about that. I have a contractor in. Didn't know the drill was going to start. Okay, so I hope this adds a little interest to the video today. So when you start talking about the, aftermarket and service parts, there's a whole process to ship those, because many times those will go through a distribution center, and then they're distributed to either dealerships, or the parts are distributed to auto parts stores. So you might have aftermarket that is packaged so that people can go in and recognize their brand, recognize the part, and it's more consumer oriented. So an example would be oil filters, right? So if you go to an auto parts store to do your own oil change, you might go in and you want to recognize the brand, the size, the particular vehicle that you have. And you need that visual recognition that you are used to seeing from a consumer standpoint. But that same, and it would be packed individually, but that same filter going aftermarket to a dealership most likely is going to come in a bigger box with maybe 10 or 20 filters in it, and it won't have the consumer packaging, it won't have the graphics and that sort of thing. So those are other things that you want to keep in mind that could come into play when you're looking at the automotive packaging. The next area for making sure that as a packaging engineer that you're proactive and you're working with your program management team is looking at things like the RFQs, which is the request for quote. So as suppliers for parts are quoting their parts, you need to be involved to ensure that they're quoting the cost of packaging, because it can really impact what's coming in. So here's an example. I worked with a company that had a supplier of injection molded parts. They were charging for injection molded totes, but they also were making the injection molded totes. So they weren't really concerned about if the returnable packs were lost. They were most likely just using scrap material. They paid for the cost of the tool, but it was a standard tool. They used the same exact tote. I think they had 2 or 3 different totes they used for everything. So these totes for them were dirt cheap. They were probably cheaper than if they were definitely cheaper than if they bought returnable totes, but it was cheaper for them than even if they bought expendable packaging and threw it away. So, but when they did the request for quote, they put in the quote that they were paying full price for these totes. So they used that as an opportunity to make a profit from their customer. So being aware from a packaging engineering standpoint that sometimes packaging is a spot that companies will look to make a profit from because no one's watching it. Just being aware of how much things cost. For example, if someone is proposing a tote, or let's say, a full-sized bin, like bulk bin like this, if you go to Uline, I think this bin costs about $300. But if you go directly to the company that makes these, it's maybe 150, let's say $200 on a bad day if your purchasing person is a bad negotiator. So if you get an RFQ and they're proposing bulk bins and they want to charge you $350, automatically they're making plenty of money. Or even if they say $300, that is a high number. So just having an awareness of what the costs for the packaging are, so that when suppliers submit the request for quotes or the RFQs, that you have a gauge for whether or not they're making money off of packaging. Other areas that you might see this would be a supplier sent in their RFQ and they had a cost for packaging. Purchasing said, does this make sense to you? So they sent it to me to get a gauge. Well, I noticed they had a hidden column in the spreadsheet. I clicked it and it said 6% margin for packaging. So right there, I was like, oh, I just saved a 6%. So, even that was a simple one, but sometimes they literally just use packaging as a way to pad a profit. And the margins in automotive are really, really slim. So being that packaging person that catches those things, it may not seem like a big deal to catch 6%, but over time it adds up and it gains an appreciation for the packaging function from the program management team. Design, again, looking at all the aspects from beginning when this part first gets built, what are the properties of this part? Whether, where is it delicate? Is it an electronic part or is it plastic? Is it class A? Just understanding the design elements of the part so that you can design a pack that meets the needs to protect it, as well as, be able to display it line side, knowing how much space you have. And then what is it, does this need to be shipped out anywhere if it's an aftermarket or after service part, for example? And then approval. It's really important that packaging is part of the approval process. Sometimes if you come into a company to do packaging and they don't have a packaging function, individuals are approving the packaging. So usually the product engineer who's developing the product might approve the packaging. And I've seen this happen multiple times where the pallet gets custom made. And that's an opportunity for the supplier of the pallet to make a profit because they can make a pallet an inch smaller and say it's custom and say it costs more. And in reality, it's probably less because they're already going to use that wood anyway, and they may use it for something else, or they may use one less stringer. So the pallet doesn't meet the requirements, but with one less stringer, they're using less material. Thus, it's a cheaper pallet, but they might charge more and call it a custom pallet. So just things like that, just making sure that you're part of the approval process, because sometimes they might also unknowingly send in parts and packaging that doesn't meet the requirements for protection or even line side. So again, if they ship a bulk bin, but the only space that's been allocated is for a handheld tote, then you have an issue. So just being involved and being proactive with program management early on really helps. And then just during the launch process, if you're able to get involved and do all these things ahead of time, when launch comes, you're not doing the firefighting. And firefighting means literally scrambling, fixing things, finding things that come in a pack where, one box for the same part, a box of 20 came in, and then the next week a box of 40 comes in, the next week a box of 13 comes in. So, now you're, trying to go out on the line and rearrange things and help them and figure out what's going on, and it causes a lot of confusion. And then you just become the problem solver and the eliminator of confusion, because it's related to packaging. Or if there's a part that looks damaged, if the packaging process wasn't organized before launch, the assumption will be that packaging is the cause of everything. An example is, I had a part that everyone was saying was scratched. It was being scratched by the packaging, even though the packaging had a plastic insert, and so I shouldn't have been scratching it when I looked at it. But I looked at the parts and they were like, look at these parts. Every single part was scratched in the exact same spot. And I thought that's interesting, because no matter where this part was in the packaging, it was getting scratched in the same spot. So then they decided to do an inspection. The inspection was, someone was buffing out this spot because it was a part of the body. It was in the outer part of the body. So it was a Class A part, and it was painted surface. So it was something that's very obvious. It was one of the first things that the consumer would see on this vehicle. So they're buffing this part out. They have a person that came in from the supplier. They're buffing this part out, happily buffing it out. They're paying them to buff it out from their supplier. But then they would take it and put it back in that same pack that was supposedly scratching the part. And then they would move the part across the aisle and inspect the part again. And they would find the same scratch that they saw taking it out, buffed it, and then they put it back in the pack, moved it 20 feet across the line, and it still had the scratch. So finally it hit me. This is the same scratch. This was already in the part. And it turned out there was some defect in that paint process, and they were clear coating it. And that what looked like a scratch was underneath the clear coat. So no matter how much they buffed it out, the paint just wasn't in that spot. But because prior to that, they hadn't had a packaging function, they were blaming it on packaging. So they had to shift that thought process and figure out, now that they had a different root cause, and that it was related to the paint process and not the packaging, they were able to fix that, save some money because they didn't have the extra labor of paying the inspector at the supplier to come in. And then they were putting extra dunnage into the packaging to protect the parts. And they also had an extra person that was doing a secondary inspection before it went on the line. So they were able to streamline their costs for that. So, those are just some of the examples of, things that you might deal with when it comes to launch. Brandon, did you have any questions, comments?
Wow, nope, all good.
Okay, good. All right. So once again, I just want to kind of reiterate these different phases. I know depending on what chart you look at, some say phase 1, some say phase 0, but basically there are 5 phases. That first one is the concept, and you're working with finance and the program team to look at how much money is needed for capital, and the capital expense is going to be the returnable containers, because in the world of automotive packaging, returnable containers are treated as an asset or capital. And then they have to do a whole process to justify that capital, because it will go up to upper management at the companies. Most of the time, minimum director, but many times based on the fact that they're spending millions of dollars. You saw the large numbers during lecture 1 and lectures 4 and lecture 5 for the beginning of chapter 2 on how many millions of dollars could be spent on this. So this means that at that level, it's going up to a VP level at these companies. The next one's phase 2, understanding the requirements, knowing the product, knowing all the attributes and vulnerabilities of the product, how that product is going to be shipped, and look at, how to preserve the quality, how do you make it ergonomically positive for the operator, and then, what are the risks that are involved. So if sometimes you maybe pick a pack that's not the most ideal pack, and you have to determine, you're not going to go with the most expensive pack, which may guarantee no damages. But now you have maybe two other choices. One that's going to reduce damage, minimize damage, but you may see some damages. You'll have a defect rate. And is that an acceptable defect rate? So, those are some of the things you're starting to consider in phase 2 when you're looking at requirements, or the second phase. The next phase is when you're really doing looking at the design. You're looking at parts, you're able to get part samples and start testing and checking out how these things are going to work once the production is up. And that's our opportunity to make changes and tweaks, and look at things like the long-term design, the sustainability of your packaging. And then phase 4, you're looking at, you're getting ready to launch. So this is where you're doing your approvals. This is where you're doing your final review. You might have the PPAPs at this point, everything's pretty much ready, and you're saying we're good to go, ready to kick off, ready to launch. And you need to do this ahead of production. So if it's going to take you, 6 weeks or 20 weeks, whatever that is, to get parts in, you need to do this soon enough so that you're doing it in front of production. So you don't want the parts to come in the day production starts. You want them to start coming in before production starts, so that you can prep, they can be staged, everyone knows where they are. If they're doing training on how to build the parts, and I think they talked about how there may be some training that is done, prior to changeovers in the Ford Rouge video. You want to make sure that packaging is available for that, so they can simulate what the actual production process will look like. So you want to do that ahead of production. And then once you launch, you're just looking at keeping production stable. So again, looking at, are there losses of returnable packaging? Are there things that were launched in expendable packaging that maybe now they're good candidates to be returnable? Sometimes we have suppliers that go out of business. Sometimes you have suppliers that move. Sometimes you have suppliers that open a facility near the production facility that you have, that they're shipping parts to. All those things can impact the packaging. Loss, maybe you have containers that are disappearing for whatever reason. Maybe you have a change in volume. So if your volume goes up or down, those are areas that from a packaging standpoint, you want to look at and make sure that there are no issues or changes. Oh, and then in documentation. Documentation is important. Yes, Brandon.
All right, so I have a quick question about phase 3. Let's see. So this is the area. So I'm curious about it because we're working with this right now, and it's like the point where you're trying to redesign your packaging and you need to find new materials. How does that process work? Because I'm just now thinking about it. I'm like, we don't have these materials in-house. We have to outsource for them. So the testing, do you get samples? Are other suppliers just like willing? Is that a thing, or do you need to, like, is it payment upfront? Just seems like a lot bigger of a topic than I once thought.
Yeah, so the short answer is it depends. One thing is that if you have a long-standing relationship with suppliers, they'll usually make samples for you and won't charge you for it. And generally, if they know they're going to get the business, then yeah, they'll be more willing to do it. If you work somewhere where they know that this company has a reputation for getting samples, and then they go with someone else and they've done all the development and they don't get any credit for it, then they may be more apt to charge you for that. So you kind of get a feel for, what's the history, for us getting samples. If a supplier feels like they're not going to get the business, they may push back. And that might be what's going on. They may have, jumped through hoops. Hey, we're going to do this, and think they were getting the business and they didn't. So you might want to get some history from them to understand, what their pushback is. Can you tell me a little bit more about these parts or the packaging? Is it injection molded packaging? Is it corrugated? What sort of packaging are you looking at?
Yeah, so we're looking to replace and so I believe it's called Instapack is the foam, the plastic foam that they used to put inside of products. So
Mhm.
looking to replace that, and initially we're just on board of paper replacements, but paper isn't always going to be the solution that we need. But we're still outsourcing for more sustainable things in plastic. So I don't know. It's been kind of tough finding some substitutes like that, but um, another question I did have is, who do you go to in the packaging team for that? Is it always just packaging, or is it the company? I know my supervisor mentioned the purchasing department, like that'll be your front hand go-to person.
Yeah, so are you in the packaging department? Are you like in production or what is are you manufacturing? What role does okay, what is your manager's title?
Yep. So he's the packaging. I think it literally is just packaging manager, packaging
Okay.
project manager.
Okay, so packaging falls under him. But if he's saying go to purchasing, that means that sometimes some salespeople will not respond or act until you, they get a word from purchasing. Because I actually have a client like that where they don't respond to me ever, and they didn't respond for months. And I'm telling them I'm the packaging person, and they wouldn't respond until purchasing sent them a message. But then I did some checking too, and you'll find the packaging world is really small. I always joke that we're all double cousins, meaning that you have a cousin that's a cousin on your mom's side, but when you start checking, you find out that this cousin's also a cousin on your dad's side.
Uh-huh.
So the packaging world is really small like that. So I did some checking and asked, who uses this company? And someone told me, yeah, we use them. And I said, what's been your experience with them? I didn't tell them what my experience was. I said, what is your experience? And they described the same thing, that they'll ship in orders when purchasing orders parts, but when you as a packaging person try to reach out to them to do work, it's like crickets. They don't want to talk. Sometimes that means it could mean a couple things. It could mean they're really busy. It could mean they really aren't a main supplier. They don't get a lot of business. It could also mean that they're overcharging and they don't want purchasing to know. And they know that if they're talking to a packaging person, they could root that out because maybe they're using too much material. Maybe they can make a design change that would save a lot of money. And sometimes they don't want the packaging people involved with that. But I'm suspecting that they probably have some long-standing relationships with the purchasing team,
Okay, that
and
makes
they respond to purchasing first. But what kind of, so if you're looking, so you're looking, are you, so it sounds like you're looking for new suppliers too, and that might be it as well, because the purchasing team is probably happy with who they use. They have relationships. The salespeople work really hard. And I used to do sales, so I know this. Salespeople are encouraged to build deep, serious, genuine relationships with the purchasing people.
Mhm.
So now you are friends and you don't want to take business away. So
Awesome.
so there are a lot of factors that could come into play with that. Um, I think that what I would suggest is, have you found some companies that provide what you're looking for, or are you trying to task the existing suppliers to come up with some of these sustainable options?
So I've looked into alternatives, so things that we don't typically source because I know most of our suppliers we're just it's just straight metal. Like we have big metal suppliers. They don't really dabble with like the dunnage inside of a package.
Hmm.
So I've been outsourcing, finding companies, looking into like you said, who's worked with them, and that's what I've been trying to keep it credible is because everything is startup right now when it comes to sustainability. So I feel like this phase three is gonna eat like it's getting even harder to get out of nowadays. But yes, everything is either a startup or they used to be a startup and they're finally lifting up off the ground. So looking into those, making sure I, as an intern, don't jump the gun. So that's why I'm talking with my manager and purchasing because I know this is their realm. So that's what I've been trying to do.
Yeah. Well, keep in mind that it's your realm too. You're doing the research, and um, it's okay to have these, companies come in and give you prototypes. So if you're working with a lot of startups, I would think they would be willing to give you some prototypes. They may charge you for them because if they're startups, they just don't have a lot of money to pay for that. So you may have to help them with the cost. But there are companies out there that are larger that, I saw at Pack Expo even back in 2019, and they are working on sustainable packs that can be used as, fillers to replace Instafoam.
Okay, I
So,
definitely gotta find that out too. I've
yeah.
heard a lot about the Pack Expo. They mentioned a lot of things coming up in that as well. So me too.
Yeah. Yeah. So have you reached out to your supplier? I'm assuming you probably use a distributor for the Instapack or Instafoam
Mm.
products.
Yeah, if I haven't yet, it's coming from a different facility. So, Black and Decker owns a lot of different companies, and we're in the middle of a merger. So I'm in contact with Legacy Excel. They're another outdoor company, and that's who we're merging with. So I've been talking to their production manager a lot, just trying to see where everybody's head is on this issue. So been kind of all over the place so far, but we roping it in a little bit.
Yeah. It sounds like you're making progress. It's a lot, but it sounds like you're making progress. And I think you're moving in the right direction. So I hope that answers your question a little bit.
Yeah, definitely.
Okay, good, good. All right. This next slide, I wanted to show it to you because this big peak here, this is showing by phase what the packaging departments look like. So many times, a lot of the work doesn't happen until like right around phase 4. So all the planning that I talked about, being engaged with program management may not happen. Everyone's kind of doing anything and then doing whatever they do and not thinking about packaging. And then when the product starts coming in and the product's not in the packaging that they want, now, there's a big scramble to try to change it. So this is more traditional, right? This next one is like the second phase. So all the things that I have been kind of talking about and pushing for program management and getting packaging involved, that would kind of be this next phase where, you're doing some information, some things up front, providing some information, asking for samples, telling people you need product samples, getting the product samples in, doing the prototype testing. So the bulk of your work would be kind of in the middle. And then by the time you do launch here, it's more of just managing by exception versus everything being an issue. So you can see the difference between the level of work here versus the level of work here. At this point, you're looking at, just making sure everything's smooth and running and confirming that things are coming in and just confirming that everything is fine. And then you have some time to tweak. But what that does is it allows more time for you to start working on development on, innovative things like Brandon just mentioned with, changing out the dunnage to something that's more sustainable. So you have more time to do those things. And then the third one really would be, future state, how do you want things to look? I think I just did these backwards. I might be a little bit colorblind as they get old, sorry. But so the next one, I'm sorry, is you're going to be spending a lot more time up front, getting things set up, putting together your standard operating documents, putting together, work standards and specifications, templates, things that you would use for every single one, putting together a framework and standards. You want to really work on that and really letting the program team know, hey, we're setting up standards. We've got standards for packaging. This is the process. This is the kind of information we're going to look for. So there's more work up front. And during this phase, you might have, actually, this shows pretty low, but you might have more work because you're pushing for the new programs where you're setting standards to smooth things out, but then you might still have some fires to fight for the old one. So, but then the last one, this one up front, I'm so sorry. This one is the one that the bulk of your work is going to be spent in the middle, where you're collaborating with people while they're doing designs. And it does give you more time and more access to be more creative and to find innovative solutions. Okay. So when you look at, and I call this cross-functional packaging development, because you're looking at working with a lot of different departments, a lot of different groups, your suppliers, your customers, all the way through. This packaging touches every one of these areas. So one of the things you can do is, you look at other areas and other industries and take learnings from those areas and industries and put it towards your packaging. And when you start looking at becoming innovative. So again, we just had that example of changing the dunnage for packaging. It allows you to do that. So, leveraging other industries to get that done. One thing is, you're working with the program team for planned project launches. You're looking at helping managing with the customer and suppliers. Material flow, which is the product coming out onto the floor. So, you see those tugger drivers, and you see when the operator uses the part and the packaging is empty, and that tote goes back, or that bin goes back and gets sent back, and the full one gets replaced with it. Those would be an example of material flow, which was going to tie into how many orders you're getting from your customer, and what's getting brought in and what's being shipped out and delivered. Things like container tracking technology and the use of data are very important for this whole process, because it ties into all these different areas. And also, besides pulling information, you also can provide information related to packaging that can help some of these functions. An example, in fact, one that I'm working on this week with one of my clients, is they're trying to figure out, they're building a greenfield plant, which I think I mentioned before. They don't know how much space they need for the finished packaging for the parts to go into these returnable packs before they ship them out. They need to know how much space they need. So I'm taking all the information and data that I have from the beginning to the end to figure out for them how much returnables, how much material they're going to use, how many returnables they're going to need to pack parts into on a daily basis, which is going to tell us how much storage they have. Things like cost improvements. Having all this data helps you determine, what cost improvements are important. And then as far as things like line side displays, returnable packaging, being able to work with the manufacturing team, quality, purchasing, supply chain, and logistics, which I didn't mention, but they're a big one. Materials and manufacturing, all those things come into play. And then if you have anything like automatic guided vehicles, racking, automated storage and retrieval systems where they have, big racks, and they just, if something comes and pulls the part out of the pick location, and then they take it to the line, and there's no person that's doing it. It's basically a robot. Or, any truck systems that they have on the floor. How does that tie into packaging? Because if you have any sort of automation where you're picking, moving, or placing a part, the packaging ties into that, because the packaging has to be stable enough so that they can determine where things need to be pulled from or placed. So packaging comes into play with all those things, and understanding the size of the part, where the automation is going to be, all those things are really important. Some other areas that are important are things like just-in-time manufacturing. So, we talked about that. That was in that video. Shop floor management. So anything where on the manufacturing floor, where, they talked about the Andon boards, for example, where, or even the andon cords in that video, where they're looking at boards or they're looking at screens to tell them, you know, how, where they are, or how they're doing, what, you know, where are they on track for their goal for manufacturing for the day, you know, those sorts of things. Packaging can play into that as well. So if, you know, if there's a shortage of packaging, or the parts come in a different package, an unexpected package, that can cause issues with the shop floor management. Things like inventory for, you know, parts, and inventory for the packaging. That's important from an automotive packaging standpoint, because if you're using standard packs, it's much easier to do inventory. So plants will shut down and they will do inventory. I don't see it as much with automotive because they'll kind of do a running inventory. But if you're in an industrial environment, they will do a full inventory, which means they shut the plant down. And automotive may do an inventory when they do their summer changeovers, where they shift to a new model, which is going to usually be in the summer, like July, right after the 4th of July, when they retool. So that might be an opportunity where they're going to actually count inventory of parts and inventory of returnable containers. So you just really want to, you know, make sure you know from the beginning how many packs were ordered. And when they do the inventory, let's say, you know, you ordered 1,000 of these packs. When they do the inventory, they only find 50. Well, what does that mean? That means that either production has to have come to a grinding halt because they only have 50 of the 1,000. Or maybe does that mean that production slowed? Or does it mean that maybe they're holding a lot of material in these packs, or the packs were stolen? You know, there's so many reasons why that inventory can be off. That's important for you to understand. That ties into storage and space utilization. So if you have enough packs and it's coming through production and they're using the material just in time, they're not going to need as much storage space as if maybe they bank build, or maybe production slows down and they're now holding more material than they plan to, either at, you know, at the customer location, or the OEM, or at the supplier location. So, you know, those are things to look at. Also, packaging comes into play when you're looking at international shipping and customs. So the way you would pack something for an international shipment that's going to go on a sea container is going to be totally different than than if you're shipping something by air across the world on a, you know, in a short time frame. So those, you have totally different supply chains, totally different packs. One, you know, if you're shipping by sea, by ocean, and it's a part that could rust, then you need to protect for moisture, because there will be moisture on the sea containers. But if you're shipping overseas, or if you're shipping by air, for any reason, that whole process is a lot different. You saw in the example, I think it was in chapter 1, where that they showed the airplane and they showed the container that was shaped like the inside, the interior of the airplane. And the airplane basically, instead of having seats, it had rollers on the floor, and they could just fill these containers and roll them. So that's a totally different type of pack requirements are needed for that. The other thing is with customs. If you're looking at customs, your border crossing can be an issue for a couple reasons. So I mentioned before the wood pallets or any wood packaging, and that whole issue of making sure that they are treated and stamped properly. That's one reason why you might have an issue, but also there could be an issue at the border with returnables. So if they're not properly documented, that could cause an issue at customs, because the returnable containers are considered to be an asset. So in their eyes, if it's not properly recorded and they show this asset coming across the border, something that's capital equipment, they could treat that exactly the same way as they would a piece of equipment with the motor coming across the border. So those are some things you need to keep in mind on, how your customs team, making sure that they have all the information on the packaging and that they document it properly, because their role, if you work somewhere that has a customs team, they would be responsible for all the documentation. But if they don't have proper information on the packaging, such as the country of origin, which would be, where the pack's coming from, as well as the country of manufacture, of where was this manufactured. Depending on where it's manufactured or where it's coming from, it has to be treated differently by the customs team. So just knowing that information and making sure that your customs team has it if you're crossing borders. The supply chain for packaging is important to know too. Another reason is when you're looking at like your return route. So if you have your packaging that's empty and is coming back, sometimes they're going through a distribution center and they're collecting them and then they're compiling them. So you might have a distribution center. If you're an OEM, let's just say that you're Ford. Okay, I'm just going to use an example. Let's say you're Ford. You have 5 different automotive plants where you're building a truck and a sedan, an SUV, crossover and electric vehicle. Let's say you have 5 different plants that make these different vehicles, but they all use this type of bin, a bulk bin with no dunnage. Okay, something like this might come through a consolidation center. Their systems will tell them, okay, today we're going to receive 500 of these and we need to send 500 out. So each plant in the system, it might show that they're all supposed to get 100 of these. However, there may have been some shift in production. One of the plants may have sent in 25, another plant sent in 75, but then they're only going to get 50 back. So understanding that is important from a packaging standpoint, because you need to know, is your fleet going to stay within a small closed loop, which means that it's only going between like maybe point A and point B, or maybe point A, B, and C? Or is it something where it's coming through, going through a distribution center, and it's going to be more of a hub and a spoke and a wheel? So it comes to a central point and then it can go out anywhere. Those are things that are important to know for the packaging design, because if you know you're sending pretty much everything through consolidation points and most things need dunnage, then you have to make sure that the consolidation points are managing that. But if you're sending a lot of parts that don't require dunnage and they're just using handheld totes or bins without dunnage, then it's not as critical to know what's going where. And as long as whatever certain plants don't have shortages. That goes back with like the next bullet, which is the return ratios, which would be, are any of these collapsible? So if they're collapsible, and let's say for every 1 you ship in, you can collapse them and ship 5 out, then that means for every 1 truck you have every 5 trucks you have coming in with parts in them, you may only be sending out once a week. You may be sending a truck, and you just want to make sure that that does not slow down or stop production at your suppliers, because they are waiting on containers. And those 2 bullets are really, dealing with some of the same issues. So I just wanted to go over some of those things before I finish up the chapter. Any questions or comments, Brandon?
No, all good.
Okay, good. All right. Okay, so now I just want to finish this up. Back to chapter 2. When we finished, we were talking about taking measurements and looking at, parts being like in and out of spec, and how those parts are measured in the automotive environment. during design and looking at different surfaces, the difference between Class A, Class B, and Class C surface, and understanding where those surfaces are, because that would affect how you package those parts, because you don't want to touch the Class A surfaces directly. You may not have a choice but to hold the parts in those on those surfaces. But if you do, you have to make sure you have like dunnage or something that will make sure that the part is not damaged. So we've finished up with that. So now we're talking about like fabricating standard containers. So the standard containers are going to be things like a bulk bin with, like those Orbis bins or handheld totes that we talked about. And they're considered off the shelf. And we mentioned before companies like Orbis, RoPac, I think we've got Bradford. There are several, Triple Diamond. There are several companies that make these, but I think the most common that I've seen have been like Orbis, and they get called, everything is called a RoPac. But in the Metro Detroit area specifically, I see many Orbis containers. So basically they're made out of high density polyethylene or HDPE. And here's an example of a two-piece mold. This one looks more like a milk crate, but it's the same process. Okay, so then when we start talking about dunnage and fabrication of this dunnage, you can take standard containers like a rack, but you can also take standard containers like handheld totes or full-size bins and put dunnage inside. So again, you're looking at this might be something that they're pulling parts out. They want to pull the parts out always in the same direction. This has lining on it that would protect probably some sort of Class A surface, but then also separates them. So if you have something like a door handle that is plastic on one side, that's a Class A surface that consumers will see, but then on the inside you have clips, because that is how they install that part into the door frame. The metal clip might scratch the Class A surface. So that's where you might see this sort of divider. Okay, we talked about the fabrication of racks, and that it takes a long time. The lead time is very long, and that's part of the whole process of developing that rack, testing the rack, making sure it works. A lot of times the rack design is done by companies that specialize in that, but as a packaging engineer, you have to make sure that you give them your criteria, and you have to understand how that part is going to be presented on the line, what needs to be protected, and that needs to be communicated to the rack designer. These are just some of the steps that come into play. So this geometry data related to the part, which you might hear referred to as math data, goes to the supplier, and they'll use that for them to understand, how big does this pack need to be? In what direction does this part need to be held? Because they can use that 3D data and they can actually rotate it and see, what if we put it in the pack this way or this way? Does that meet the operator's ergonomic standard? Is it going to protect the part? Those sorts of things. Like I said, here we talk about, how do the parts need to be held? Is it Class A surface and they can't be touched, or do you need something special to make sure that it keeps it in place solidly, but it doesn't scratch it? How are the parts going to be accessible? How are they going to be pulled out? Or is anything going to be reused? How many parts per pack are needed? So there usually is a goal. That goal is going to be based on the takt time, or the speed for the cycle of making one vehicle or making that part. They try to minimize the use of steel for the cost, and then there will be a target price. Usually when I talked about the whole budget, that's where it's important from a packaging standpoint to get involved in budgeting early in that concept phase, because if they say, oh, these racks are going to cost $500 and you know the rack's going to be $1,500, then it's going to be a struggle and they're going to be short money. And that's not a what if scenario that I've actually had that happen. Okay, so here's some bullet points for the development process. You know, getting that CAD or that math data, looking at other racks that are already in use, try to leverage that same design or something similar, because for one, your facility will be used to that style of rack. So if you go from, you know, having a rack that, let me find it. Go back really quickly. Okay, so let's say that the operators are used to seeing racks like this for most things, but then you bring in racks that have arms, that could slow down production, because unless they have training and they get used to it, this could slow them down because they maybe not know how to open this and they may damage some parts in the process. So, you know, you want to avoid introducing extremely new things into that process. You want to try to keep things as similar as you can for them. You know, just basically these bullet points are all things that would be considered requirements for your supplier that you want to provide to your supplier. In addition to, you know, you want to make sure you order parts. So remember, before I've said several times, have an understanding of what parts you need for all of your packaging designs, because if you don't, you will not be able to run testing. So here, for example, you want at least 3 parts for your prototype review. So you want to find out when you need those parts. Sometimes the parts are really hard to come by because they're still in development. They haven't even figured out exactly who the supplier might be. The supplier doesn't have all the material yet. The supplier might try to charge you, which is what your question was, Brandon. You know, I've seen not only suppliers trying to charge for packaging, but also they will try to charge the packaging department for the parts. So, you know, that's something that you want to be clear with purchasing on, you know, who's paying for these parts, because something like this most likely would go into the budget of development, the development of the part, but it depends on, you know, what the agreement was with purchasing early on. You know, this says here you want to looking at some high-risk designs to do a DFIMA, which is a design failure mode effect analysis, which is something quality department does in general. But you want to go through this process where you want to see, you know, what will break and how would you, you know, so that really tells you, if you do this analysis of just find out what the failure mode on this part is, and you find out that it can't withstand going, you know, it can't get wet, or maybe it can't take vibration, or maybe it's sensitive to electrostatic discharge, or it's really sensitive to being dropped at a really low height. You know, this might be something that on a rack, if the fork truck driver brings it in and sits the rack down, that could be enough to damage the part. So those are things that you want to be aware of. And doing something like this failure mode analysis will actually tell you, you know, really what you need to protect from. So when you're looking at the concept phase, you know, you're looking at, you know, having a 3D model or the math data, and then you could and you can also do that Ergoman analysis that we talked about, because part of that design is making sure this is something that's usable by your operators. And this is the chance to make changes. So a lot of times, not just for racks, but for other packaging, you'll see this across the board where, you know, let's say, even if it's corrugated box, the box company will bring in a drawing and they'll want you to sign off on it. this is your chance to make changes. Just because they present you a drawing doesn't mean that you sign off on it. You know, it's like any contract. You can, you know, recommend changes, make changes, because this is basically, it's not a contract, but it's similar to it where you're saying, okay, this works. This is what I want. This is what I don't want. This is your chance to make comments on it. And you see, it looks like they've made several changes because they've crossed out several times multiple dates, which means that this is going back and forth and they're making modifications and changes based on new learnings. Another thing this talks about, you want to make sure that these racks can be fabricated, that they can be manufactured. This just shows, you know, some examples of that. And that's even before the prototype phase. So now you're ready for getting a prototype. So you've looked at, you know, making modifications on the design, looking for vulnerabilities in the part that you're to protect for, making sure that the racks are manufacturable. Now it's time to get a prototype. So again, these prototypes are going to be more made with more manual labor. The rack process is fairly manual, but they will try to replicate how these going to be made in manufacturing, but that's part of what this whole process is. This process may not match exactly the process that's used to build these racks in the prototype phase. But more than anything, you want to understand, you know, how much material is going to be used for a rack, whether the parts fit. Are the part, you know, will these hold the parts the way that you need them? You're going to have any issues, say like center of gravity, or they can be difficult for people to handle. Are they going to be, is it going to be easy for people to pull parts from these racks? So, you know, those are all the things that you're looking at. This is something that you would bring into that like design and validation phase and all the test builds. This is what you'd want to have in there. Also, this helps them to understand like what material the supplier of the racks or other material or other packs, they need to know, you know, how much material do I need? Because they can estimate, but then once they actually do that estimate, they'll see, okay, we aren't going to use as much material as we thought, or we're going to use more material than we thought. Or, you know, when we started making these, we found out that we actually needed to put more support in this particular part of the rack, or, you know, we needed to put more arms here. We need to change out how this articulated out. So this is their chance to really see, does the, you know, their build drawing actually match what they're building, and they can modify it from there. Again, you know, that prototype build, it's giving them a chance to see, you know, kind of a trial run, dry run of a very small number. But then when you start looking at mass fabrication, you know, it's a little bit different. So it's not completely automated at all. There's still a lot of welding. You know, some companies may actually have some automatic welding in there, but there are some rack fabricators that do not do this with any sort of automation. They will do all this by hand. But when it comes time for full production, they will build fixtures so that they can hold the parts and make it easier to produce them in larger quantities. So when they make them, you know, they cut, they weld, they clean them, and then they paint them. So that usually it's like a powder coat. So that protects them from rust, but it also, you know, they can paint, they can pick a color that either, you know, matches their company theme, or maybe different racks for different areas, because sometimes you might have in-process racks that stay within the facility, and then you have other racks that get moved to and from within the loop. So, you know, this helps them to know, you know, if let's say you have manufacturing and the supplier is saying we're out of racks. Well, if you look around and you see you don't have any more orange racks, that means you don't have anything to send. You may have a bunch of, you know, black racks or red racks or whatever rack you might have, same style that would work for that supplier, but if you sent them, then you won't be able to get your production done because those racks are in process racks. Okay, so I did mention the color coding. So again, you're not going to go into a plant and see like every line has, this is the red line, and this one has blue, and this one has purple, and this one has yellow. You're not going to see that. But if you do see any differentiation in colors, it's usually going to be because these are the ones that stay in our building and the other ones go out. That's pretty much what the color coding looks like now. Okay. So the fabrication process, which is, when they go into mass production, it's called a first article. So you'll see this for parts, for racks and other packaging material. They'll have what's called a first article inspection. So that is really like that last validation when we're going through the whole phase of, running through testing and pre-approvals. This is what the sample that they get before people start signing off and approving this rack. Let's see. Okay, so we'll talk about container management and tracking, and we'll talk about this some more too when we get to like fleet management and fleet calculations in later weeks. But for container management, every pack will have a part number. So, this, for example, this has a part number. This would have a part number, this, a tray like this, and then this pallet would have another part number. So across the plant, anyone that would use this pallet, they use that same part number. For something like, let's say this one, for example, this would have a part number, but if you have special dunnage inside of it, that dunnage could have a part number. But if this is affixed to this tote and it always ships with this particular tote with this dunnage in it, then that tote with the dunnage that is attached will have its own part number. All right, does that make sense? So Brandon, I'd love to hear your feedback.
Yeah, it makes sense to me.
Okay, all right. So you have, part numbers, and the part numbers, many times they'll match. They'll be similar in format to the parts, because that packaging usually will go into what's called the BOM, or the bill of materials, for the part. So the part will have a list of every part that's in it. If you were to open up that bill of materials list, you would see, this part has a plastic casing and screws and a metal bracket, whatever it has, you can see every single part. And depending on how that company's set up, they also could have the packaging attached to it. So you see the part number for the pack in there as well. And if there's dunnage or any sort of inserts or anything, that would be listed as well. Let's see, I'm just gonna say about this. So this talks about, holding, having the standard pack size. You want to keep that the same. And that's one of the reasons why you have standard packs, because if you have standard pack and you always put 20 parts in this bin, then you can, do faster inventories, because if this is a full bin and you see 10 of these, that you have 200 of these, of the parts. Same thing is, if you have standard totes on a pallet. If you have a pallet that holds 20 totes, then you see that pallet, it's full, and you can assume that there are 20 totes in there. So, it makes it a lot easier for things like counting, part delivery to the line, and those sorts of things. Here it says that there are multiple part numbers being installed in each workstation. there would be multiple containers sitting in the pick face of that workstation. So what that means is when we walk through that video of the Fort Rouge plant, and if you need to go back to it, feel free to do so. But when they were walking along the line, you probably noticed that there were, racks that were holding bins, and you might see some green bins, you might see some purple bins, and you might see some boxes, but those were all different part numbers. So for every pack type, that was usually a part number in that row. And then you might see another green tote. Sometimes you might see two green totes, on the same rack, maybe sometimes on the same level. Sometimes you see one on the next level, but generally each of those positions represents a different part number. So the operator knows that whenever I go to this spot on the rack, I'm always going to pull part A. When I go to the third position, I'm always pulling part C. So they know, there's those racks are dedicated to a certain packs and certain parts in those containers. So it's kind of like, if you know anyone that organizes their spice cabinet and the spices are always in the same spot, you open their spice cabinet and the salt's always in the same spot. But if you ever go and you mix up their spices, they can't find their pepper because they always put their pepper right in the front and the bottom, for example. That's basically what this is. This talks about how, this is where I mentioned before, it's really important to know what sort of line side racking or display or space you have, because if the space is allotted for bins, for handheld totes, that's maybe a 12 by 15 by 9-inch tote, but the supplier is trying to send it in a bin that's 48 by 45 inches, there's not going to be enough room for it. So those are just some of the things that you need to know. Let's see. So this talks about, okay, so for example, this says if a plant needs 860 parts per day, right? The standard pack size is 100. So they need to figure out how much they need, how many packs they need. This tells them that they would take the 860 parts divided by 100 parts per pack, which means they're going to turn that tote over. They need 8.6 packs. They need to deliver 800. These 100 packs deliver 8.6 times per day, which means that they're going to get 9 containers, right? So what do they do with that extra material? This is where I talked about it's really important to know what the requirements are, how fast they're working on the line, because if you got a station where all these parts are put in at the same time, and one of the bins needs to be delivered or it turns over 8.6 times a day, but then another one turns over 10 times a day, another one turns over 3 times a day, that route driver is going to be, that means that route driver is going to have to deliver at least 10 times a day, because the one that needs to be delivered 10 times a day is going to run out 10 times. So that driver has to come and do the route and deliver and pick up empties 10 times a day. However, that 8.6 may not coincide. So if you deliver 10, now you're going to end up with you're going to end up with almost 1.5 extra containers sitting at the line every day. And that's going to add up over time. So, after on a Monday, they're going to have 1.5 containers extra. They keep delivering 10 times a day. Now, the next day, they're going to have, about 3 containers. So by the end of the week, they're going to have quite a few containers that are just sitting there that are, full of material that are backing up, which then means someone has to do the calculation and say, okay, we need to not deliver these this time, but the route drivers are set up to be very predictable and just pick up the same thing every time. So now they have to stop, they will have to pick up something different. So it can cause a lot of confusion on the line. So this 8.6 I mentioned, it's going to be rounded up to 9 because they're gonna pick up 9 totes regardless. So this is basically what I was saying. You know, you have to kind of, a lot it goes into, you know, how these containers get shipped, in how they get delivered. And it's really important to try to work with the logistics team, supply chain team, materials management team, all the teams that are, you know, looking at the delivery as well as what's getting used on the line to try to balance that out. So it's a big balancing act. So especially as we look at an automotive plant where we saw that picture of the disassembled car with 5,000 or 6,000 parts. So it can seem to be a bit overwhelming. And that's why it's important to have standards in place. The things that don't change, that are, you know, pretty static, you know, you want to have that established and put in the standards already, so people don't have to think about those. And then you manage by exception. Okay, so this one says if the container is a unit load, which means totes on a pallet, that it might not get rounded up. Most of the time it really would. It says because it's possible to create a fraction of a unit load by removing totes. So most of the time people don't do this, but it's possible. But you can see how quickly this can become very tedious for people that are ordering the material and handling the material. If now you're adjusting 1 day to shipment, you know, every, you know, once a week or every couple of days, you gotta adjust the shipment for one part, and 2 other ones you don't have to make adjustments for. So that's why you want to know kind of what's coming in sets, you know, what parts work together. So let's say that, so you don't get the, what I mentioned before, the order a pack of hot dogs, and then you order a pack of hot dog buns and they never match. So you have to buy, what, 48, I think, before you get to your match, because you got 6 of one, 8 of the other. So they're not gonna match up until you've eaten 48 hot dogs, right? So, you know, it's kind of like that, except times 6,000 parts. Okay. Labels. So, you know, labels are used throughout to communicate, you know, what the material is. There's a standard format for these labels. So if you look, not just in automotive, but in a lot of industries, the labels will look very similar. So you're going to see the human readable part, which is a number, and then you're going to see the barcode. This is an AIAG standard, again, the Automotive Industry Action Group standard. And if you go into automotive, like I said, you will see this everywhere. If you walk into an automotive plant now and you start looking at labels, you'll see all these labels really look the same. And it's based on, you know, this format. If you took these numbers and barcodes out, these windows, the order of these of these different areas will be the same. The numbers that you see, this is the part number. The quantity will be here. You'll have a supplier code. If there's kind of serial number, and then if there's a supplier part number, this is here. They also can attach a PO number to it and a lot number. So these are things that are pretty standard. So these all have to do with really traceability of the part. And it will be on the label. So like I said, there will be, most of these containers will come in with a white, it's like a white sticker with a shiny back on it. And you can stick labels on that and peel them off when this tote is emptied. So again, this is the information on the label that I mentioned before. You've got part numbers, supplier information, PO numbers, lot number. This is if the lot number is used if there is an issue with defects for the part. If they have a hole for something, they can go back and find this lot and say, we've had so many defects in this lot, then it's time to inspect. So they'll have a rate for defects and say if it's more than that, they'll do an inspection. Inspection could be where they go through every single part, and depending on how they're set up, they may actually set up a full site for inspection and inspect every single part. That would be an example that example I gave about that part that had the paint defect. And they said it was packaging, and they were taking every single part and doing an inspection on every single part. So that would be an extreme example, but the lot number can be used for that. They can determine, are we having an issue? So for example, with that paint sample, they could see with that paint defect, they could see what's happening in every single lot. That's why they determined every single one needed to be inspected. Versus if you find that the defect is only happening in certain lots, then what can be done is anything that's from that lot and is deemed to be a problem, they can pull anything that was made in that particular lot and either send it back, inspect it, and inspect out the bad ones, or maybe they have a repair or workaround or something. But they can make a decision by lot, and they can identify that based on what is on the pack, the label on the pack. RFID tags are used. It depends on the company. I've worked at companies where they used RFID tags and they even serialized the containers. Sometimes RFID tags are used to identify containers and track containers, and then they can track the product in it. Sometimes it's used just to keep track of those containers if they have an issue with loss of containers. But an example I gave earlier was, using RFID tags for radios or sound systems. So if you have a serialized product, and we'll go back to saying these are sound systems, and every vehicle gets a different sound system, they know that when this particular bin comes by or this tow comes by, they can scan, or if it's an RFID tag, it would go past the reader, and that reader would say, this is the bin for customers number 21 through 40. And they would know, okay, we're on vehicle number 21. So they would know it comes through here. And then when this tote is empty, the last one should be used on car number 40. So for customer number 40, if they get done and they see, oh, wait a minute, we have 3 more radios in here, that might be an issue, but RFID can help them with things like that. So the barcode is visual. So, someone would scan that. That would be when you go to the grocery store and you're scanning your groceries at the scanner. That would be an example of how a barcode reader is used. An RFID tag is read by a scanner, but that scanner it takes the information. So it's like an example would be if you go into a store and when you leave the store, if you have the tag on the clothing still, it will beep. It's because it read that RFID tag and it identified that this should be in the store. So that's the difference. One is a visual read, and one it can detect that tag has passed through. And when that tag passes through, what it does, it takes the information that is transmitted from that tag. It says this should be, this should go back in the store, or this should go on the line. That's kind of the difference in very rough description. Okay. We start talking about the shipping cycle. This is tied in with having a new model. And I mentioned, when they do supplier selection, they're looking at things like, does the supplier have the capacity to make enough material or make the rack or the pack? How far away are they from the receiving plant? Will they be able to respond in time? If they're JIT, you want either a very, very good forecast so they can plan and predict that out, or they want to be nearby so they can accommodate and respond very quickly if they can't supply just in time. without that. When this also is kind of talking about when the orders are coming in. So it gets kicked off because the OEM or the supplier or the customer, whoever that customer is, sends out a release, and they're looking for, how many do we need, what's coming in, when does it need to come in? And it really is like the order. It tells them it's okay, we want you to ship this out to us. And when they get that release, then it tells them, okay, now we're gonna, if we haven't already made the parts, then we will order the material for it. But generally, if they're JIT, they're gonna have enough material on hand to handle that. But this kind of kicks off that they can pay for it. They will get paid for it, I guess I should say. And this is really like, this is talking about really like when it's first kicked off, when you're authorizing the pay. So the first time this happens, once they kick it off and say, okay, it's time to start making this, please start making it. And then the customer will start paying them. So let's see what else. When the supplier is ready to ship parts, they send out what's called an ASN. So the release kicks off the orders, to start with, but then when they are ready to ship the parts, the supplier will send a notification to the customer to say, okay, we got your release, we got the permission to make this material, we made it, and now we're shipping it. So we're sending you a notification that we're about to ship it, which is where the ASN comes from, Advanced Shipping Notice. And most companies, OEMs, they all use EDI, which is an electronic data interface, or some people call it interchange. And basically that information is going, they're relaying information back and forth between the OEM and the supplier. So it will give them information on things like, how much we need, how much we shipped, how much we think we're going to be needing in the future. And this information all ties in together. So they say, okay, we're going to need 100 parts. Okay, we made 75. We're in this order, we can only fit 75 on the truck. So we're sending you an advanced shipping notice that in truck number 1, 75 are coming. In truck number 2, the ASN will show that another 25 are coming. So they can they can really predict what's coming by truckload. Talked about that once alerting. So then once these trucks get to the OEM, they have that ASN, they want to compare it to make sure. They just put it into the system and say, okay, we received 100. Every once in a while, there might be a shortage and they may be able to track that back. But they'll deal with that with discrepancies when that happens. But in general, the way things are set up, that's another reason why it's so important to have a standard pack and a standard quantity per container. Because if we know that they've ordered 100 and you can get 25 per container, then we know that 3 of these came, in the first truck, and then, 25 came on the second truck. But they're all full containers. So it's very easy to do that. So they can pull, 4 containers and send it that way. And that helps them to reduce the number of discrepancies as well. There is a process for discrepancy. So you see the RDR, which is a receiving discrepancy report. And that's part of the contract that was built early on with the purchasing group for materials. Then it generally doesn't happen with the packaging. You'll see a whole different process for packaging. So let's say that they're planning to receive them in returnables, but they get them in corrugated boxes or expendable packaging. Then what they're saying is, well, these are already paid for, but since we're sending you these parts in an expendable pack, that's an extra cost that we weren't anticipating. So, we improve that we don't have any containers, not due to our fault. So then they'll charge extra for that. That's a whole other process. But this kind of goes through the whole process on, what this looks like when they receive the containers and the parts in them. And then once they're done, once those containers are empty and, they've picked up the empty containers from the line side, and then they bring them back, put them on the return truck, then they do another ASN. So this is something that, this is me, I'm going to tell you, if you're working automotive packaging, at some point you want to kind of learn, what they're putting in the ASNs for return containers. I've seen ASNs that say empties or empty, and then let's say it's crossing a border or something, or when it gets back to the location, it's actually an empty trailer, but it should have had empty containers in it. That is an opportunity for someone to intercept those containers, and they disappear. And the ASN just says empties or empties or empty. So it's very unclear whether or not there were empty containers on there for return. And, because it didn't say returning 50 of, pink bins, part number 1, 2, 3, 4, 5, 6, with the description on it. So that's something you want to make sure that the ASNs are clear from the shipping department and the receiving department, because that is an opportunity for theft. So it's not on the homework or anything, but I thought I would mention that. Looks like I'm running out of time, so let me get through this a little bit faster. Again, returnable containers are categorized as capital assets in the accounting system, and they have to be treated like parts and equipment. And this is probably one of the best statements in here. This is not always the case in the auto industry. Very often, the OEM does not know what containers they have or where they are, so they are forced to use expendable packaging. Some suppliers even profit from this. Yes, I can talk about that later. We'll run out of time, so I don't want to talk about it now, but I could give you some examples when we get to the fleet calculations within the next few weeks. Those transactions where I talked about the ASN and the RDR, those are standard formats as well. So you see the standard label, but the way the ASNs look and the RDRs look, they also follow the AIAG standards as well. So you can go to their website, aiag.org, and check out what they have. You can actually just see some of the activities. I think there are a few standards you can download for free, but more than likely they'll try to get you to join to look at some of the standards. I have some of the standards, so if you ever want to see what some of them look like, let me know. But generally, so I think some of these things like the ASN, for example, that should be pretty much easy to see on their website. And this happens for every shipping cycle. A lot of times it's automated. It can scan it, read it, and get it in. Sometimes they have to type things in to confirm, but it's pretty routine, and there are people that are dedicated to that. We talked about maintenance and repair of the racks and dunnage and packaging in general before, depending on what it is, if it's something that has a lot of oil or something sensitive to water or dust, those might need to be cleaned more often, or if they're, racks that are broken and tend to be broken, you can put together a repair process for that. And I talked about that as well. There are ways to repair bins. So if you have like a handheld tote, they can do sonic welding to repair those. For the larger bins that have doors, they have spare parts for like doors and hinges, and they can replace those things too. So there are some processes to replace these things. Cleaning, a lot of the suppliers that I've seen in companies, they will require for the packaging to be cleaned. However, it doesn't always happen. So if you are working in an automotive facility and your parts are sensitive to oil, you want to make sure that wherever those oily totes are coming from, that if it's a consolidation center, they need to make sure that they're segregating those oily totes and not sending you any of those oily totes. But these are some examples of things that might require cleaning. I've been in a facility where they actually try to clean the totes, and that didn't work too well. So, okay, so I guess that's really the end of it. So I thought I had more than that, but my computer is not being friendly today. So, okay, so things to look at, things like oil, dust, metal shavings, things like that can cause a lot of dirty containers. If you have, say, a machine shop that's making machine parts, they'll have a lot of shavings. And if they are using those totes or those bins for the WIP or work in process inside their plant, and then they turn around and use them to ship the parts out, then you might end up with dirty containers. And that could be an issue too, because you get those containers that are dirty and then they come to your facility and they can contaminate the parts that the packaging, that those parts are in that package, or it might contaminate something else. And then another thing is, when at all possible, you want to avoid storing them outside because they will get dirty. And I have a story about that too. I have one company that I worked at, and they were, and I'll try to find that picture at some point too. They were bringing in, they had 3 or 4 locations that used the same package. One of the locations kept saying, we are running out of packaging. So every month we were spending about $10,000 to buy new packaging for this particular pack. Because what they were doing was they call every month to say, we're out, or maybe every week, we're out of packaging, we need more. All the other plants were like, oh, we have extra, here you go. But then they were like, now we're short, so you need to buy us packaging. So we're like, where are these containers going? Are they getting stolen? What's going on? You know, I'm looking, can't find anything. I'm like, well, it doesn't look like they're getting stolen. They're coming in definitely to the plant. The plant is making their production. Where are they going? Something told me to go to Google Maps. I Google mapped this location, and you could see this big spot in their backyard full of these containers. They were getting too many because they're like, we need some, and they would dump them in the back and go, well, we'll pull what we need. When we need them, we'll pull them. But then they sat there for so long, they got dirty. And they had bugs and critters and everything. So then no one wanted to go back there. No one wanted to deal with spiders or scorpions or rats or whatever it was they had back there, snakes. I don't know what it was, but they didn't want to go back there. So they just let them pile up. But this pile was so big that you could see it on Google Maps. And it was bigger than, and you see the little, the 18-wheeler trucks, the 53-foot trucks looked like, almost like little cubes on there. Oh, I see you're laughing, Brandon. Okay. So I can tell you those stories all day long, but these are the reasons why these things are important. Okay. So besides your laughter, Brandon, did you have any questions?
Yeah, I did have a question about the returnables towards the end. So mentioning the cleaning process and all of that, are these the same? Do they use the same returnables that they use in their testing procedures? Because I worked in the distribution facility, and we used to like bang those racks up, and like they'll get dust, and like you said, metal particles, they'll be all over the place. So are those the same ones, or do they have designated ones for testing that they send out?
So I would say that they probably weren't designated ones, because are you saying they were testing the racks, or they were using it to test parts, shipping those parts?
Like specifically that the rack that had the bag slots in it, we used to test for automotive companies. They'll send their headlights in those, and yeah, they'll get tested inside of the rack.
Okay, so then I would say they probably were just using those for tests, and they were cycling them through. Mm-hmm. But I would say that you know, if you're testing those over, if you're testing, if they're just shipping them over to get the headlights tested, they probably just had, they were probably using them similar to the whip work-in process. But if they were using those racks and running like distribution tests over and over again for headlights with those racks, that's probably not, that probably wasn't going to be long-term a good test, because at some point those racks are going to wear out and they probably weren't going to have, the results weren't going to be as good in with the racks as they would be with newer racks that were maintained better. Does that make sense?
Yeah.
Yeah. But, you know, people get into their habits and, you know, they'll, if they're just using them to ship them, it's probably not a big deal. But if they were actually using them to as part of the test, you don't want to use worn out racks for that.
Yeah.
So that would probably be the worst case scenario.
Okay.
Okay. So I just want to go over the homework really quickly. Again, anybody has questions, let me know. You know, if you have any, you know, if you have any calculations, make sure you show your calculations. But most of these are like the first one, you know, this one you can get from your reading. We talked about the different phases. You know, how many cars, if you're for this during this whole pilot phase, how many cars are going to be built as pilot vehicles before the launch? The next one is, you know, if they're changing, this is talking about that rack fabricating process, how they were saying, you know, they had to have, they're building so many racks and they didn't want to put all their eggs in one basket, right? So if they decide that they want to build what they initially, during that example, I think they talked about 28 weeks to get the racks done. If they want to start building 15 weeks before the launch, you know, how is that going to impact each fabricator? And then how much the fabricator's capacity of each one is going to be used. So you can see in that example of the 29 weeks, they were using, you know, so much per capacity for each of those suppliers. But if they push it up to, you know, 15 weeks versus 29, what's the difference? What is that going to look like? Number 3, so basically, why does a fleet of modified standard containers cost more than a fleet of standard containers? So just explain that. The next one is the kitting. We talked about the kitting process. So, you know, what are kits and why are the kits used? You know, what is the reason that the kitting process exists in the automotive space? Okay, so when you look at the packaging, what's likely to have the greater density, you know, unit loads or bulk bins? So remember again, you know, this is a bulk bin, but then the unit load is going to be a pallet with, you know, trays or something, or small bins on them, and they're going to be parked inside of those bins on a pallet. So you might have, you know, like 10 or 20 pallets or something, like 10 or 20 handheld totes on a pallet versus one bin. So, you know, what's going to yield you the most density of parts? Number 6, this one, you know, make sure you write down how you came up to this, how you came up with the number. But so when you start talking about manufacturing tolerances, which one has the smaller tolerance? Auto parts or the shipping racks? So other than the examples that were given in the reading in chapter 2, like I think what is it, automotive glass was one, you know, give, and I think the doors were another, you know, give an example of what would be a Class A surface that was not given in the notes. And then number 8 is, why is the level of assembly important? And then number 9 is an assembly plant needs so many seatbelts produced per day, and they're putting 20 seatbelts in each tote. Now the standard pack is going to be the tote. You're going to have 48 of these totes on a pallet. So saying 48 totes, I have to look at this again, because you're having 3 by 4 per layer. So you're gonna have 12 per layer, but it's saying 5 layers. I think I need to look at that. I need to look at that one. I might need to put some notes in the announcements for this one, because it doesn't add up to me. And I have to read, when I looked at some of the notes before, the notes I have, it added up. So I need to clarify that a little bit. Okay. So the suppliers delivering these parts in multiple unit loads, and then 1 partial unit load. How many layers should the partial load have? Okay, I'm gonna send a clarification on that, because that one's not very clear. Okay, so true or false for number 10. The B10 label that we just talked about contains a part number for the shipping container. Is that true or is that false? So that B10 label, when you saw the list of everything that it contained, does it contain a part number for the shipping container? What was that in there? So those are the questions. Let's see if I can find. Yeah, I'll just go back for number 9. I think that there's a typo on that, to be honest with you. I'm gonna look at that again. And yeah, I have to look at that again, because I don't know if that, I think that should say 4 layers, because if you have 3 times 4 totes per layer, that's 12 totes. And then that should be 4 layers high, because you're not going to get to 40. You're not, if you have 5 layers high, you're going to be 60, but it's saying you only have 48 totes. So I'm going to clarify that in the homework, because that one's really bothering me. Okay. Brandon, before we wrap up, comments, questions? So you're acting as a spokesperson for the whole class, just so you know.
Yeah, I'm all good. I'm all good.
Okay. All right. So I'm gonna this one. Let's see. There's nothing else here. We just have a few more minutes. As we talked about the pilot phases. Okay, so that one homework question that we talked about, this is really where you're looking at. We've got the different fabricators and their current capacity. And the current scenario is talking about the 29 weeks. So that homework is saying they're shortening it from 29 weeks to 15 weeks. And that seems pretty aggressive, but actually that's pretty common within the automotive world, where a last minute change is being made. So just be aware of that. And that's another reason why it's really important to stay in front of the processes and understand where things are with manufacturing, because otherwise sometimes you get, pushed to develop a rack in half the time. I've actually have had that happen. had someone that in purchasing, they decided that they were going to save money by using existing racks. The issue was that the racks, product did not fit in the racks. And they're like, oh, we could just modify them, but the product didn't fit in the racks with or without modification. So, and they were planning to ship these overseas. And it was very interesting. I honestly don't know what they ended up doing with that. So I think what happened was the supplier ended up making their own racks and they ate the cost for it. But it ended up, I'm sure that the next time they did business with them, they probably charged them a lot to make up for that because they lost money on that. That's what I say, I don't know what happened with that. I don't know if they continued supplying or if the next time they had a project, that if they overcharged them for it because to make up for that, because they definitely lost money on that. Let's see. I don't know if there's anything else. No, I think that's it. Okay. All right. Well, this is your last chance, Brandon, to ask any questions.
Oh my god, definitely got to go over the middle section of these notes though, because I didn't make it to the lecture for that one.
Okay.
So I will have some reading to do this weekend.
Okay. All right. And to everybody else, as you listen to this video, I'm going to post it within the next 2 hours, just depending on how long it takes for this thing to download. But I will post it and I will, like I said, I'll be available tomorrow for office hours and look forward to talking to everyone. Okay. All right. Have a great day.
All right. Peace.
All right. Thanks. Bye-bye.